So let's talk about how DNS works in Twingate. And before we go into the details of why it works the way it does, let's take a little bit of a shortcut and first explain what the normal behavior is. And a couple of things to know if you're going to work with DNS queries and DNS tools like dig, NSLOOKUP over Twingate using private DNS servers. I think that's going to be more interesting for people, and then we can go into the explanation as to why it works the way it does. So let's take a look at the normal behavior of DNS. Just a quick recap. When a user tries to connect to a fully qualified domain name, in fact, whether it's a fully qualified domain name on a public domain like lego.com or a private domain like corp.int, for instance, or really anything else, what happens on the machine is that the request for resolution is passed to the operating system, and the operating system checks its list of DNS resolvers. That's usually an ordered list, and so if you're connected over Wi-Fi at home, there's a good chance, for instance, that your primary DNS resolver, as known to your operating system, is the resolver that lives with your router. And so if my LAN is over 192.168.1.0/24, there's a good chance that my router, provided that it's at 198.162.1.1, is going to act as the resolver. And what happens there is really the DNS request is sent to the router, and the router sends it to your internet service provider's resolver, and that is going to give your router and your machine a response as to what public IP corresponds to your public domain. Now, if you do the same thing with a private fully qualified domain name, then typically that's not going to work from home unless you have a private DNS at home, in which case you probably change the DNS resolver on your machine and maybe actually on your router. But this is typically how DNS works. And so if we take a look at that right out of Twingate, and I'm going to do it on a Mac, but it's the same thing on Windows. If we do a dig to something like whatsmyip.org, it's going to give us a public IP address of a server that serves whatsmyip.org. And if I do the same, but on a resource that exists only in my own private network, knowing that I'm not connected to it, I'm not getting anything. I'm getting an empty response because Zeus.lan is obviously not a public top-level domain, and so Zeus.lan cannot be resolved by my internet service provider or the resolver that I have. Now, let's see what happens when we connect to Twingate and we try to resolve the same resources when Twingate is on from a different network. So I added in my environment here, Zeus.lan is there. It's actually not this one. I think it's this one, Zeus.lan. And I also have whatsmyip as a resource in Twingate. That means that traffic for whatsmyip and for Zeus is going to be intercepted by Twingate, by the Twingate clients. But how does that interception actually work is the interesting part. Because right now, if I did a dig of whatsmyip.org, you would think perhaps it's going to return the same IP address, but in fact it's going to return a different IP address. It's returning an IP address that is what we call a CGNAT IP, which is a public range of IP addresses that cannot be reserved for any private use. That's what it is, right? So it returns a CGNAT IP, which is different from the real IP of whatsmyip.org. Now, if I do the same on my private domain, I'm going to also get a different IP, you'll notice, but it's also a CGNAT IP, which is different from the actual IP that you would expect. I'm going to spoil it a bit, but the actual IP of the server is this one. So it's not giving the real IP address on the private network for that resource. Now, if you wanted to retrieve the actual IP address, what you would need to do is you need to do two things. You will need to, being outside of your network, you need to make sure that your DNS is declared as a resource in Twingate so that your Twingate client can reach it. So this is my DNS server here. And then what you would need to do is you would need to change your commands for dig and nslookup, for instance. And for dig, what you'll need to do is specify the actual private IP address of your DNS server. And if I go and do this now this is returning the real private IP address because I'm sending the DNS lookup query via the dig command to this private IP, which happens to be my DNS server in my private network, and that happens to be a Twingate resource. So the dig command gets sent to the Twingate resource and the response gets sent back to my client. This way I get the real IP address. Right, so remember that the normal behavior is actually that when you're going to go and do a resolution from the client, you're not actually going to see the private IP address or the real public IP address if it's something like what'smyip.org. You're going to see an arbitrary CGNAT IP that is determined by the client, and the reason we do that is so that the client can intercept fully qualified domain name traffic properly without interfering with anything else and send it to the connector. So just remember that if you're going to do DNS over Twingate, remember to direct your DNS queries explicitly to your DNS server, and remember to declare your DNS server as a Twingate resource. Now, let's explore the why that is and what the client actually does. Okay, so why does Twingate return a CGNAT IP for public and private fully qualified domain names? The reason Twingate does this is to make sure it intercepts the right traffic. And the client, whether on Windows or Mac, really does two things once it's online. So you know that the client knows the list of all resources your user, based on what groups you belong to, has access to. But what that means is that in reality, the Twingate client inserts itself as the primary resolver on your operating system. So if we take a look on my Mac and take a look at the first resolver, this is my current DNS configuration on my Mac. The first resolver is over 195, 0, 251 to 254. Those are private IPs. They're really embedded in the Twingate client itself. And so it means that the client comes with its resolver so that the client can intercept all requests for fully qualified domain names. So that resolver is in fact the Twingate resolver. So you expect this to be there when the client is on. When the client's not on, you're basically going to expect resolver number 2 to be as resolver number 1. That's the first change that Twingate does. And that ensures that Twingate, via its network interface, can respond to the two DNS requests. Now, the second thing that Twingate does is that it's going to also change the routing table locally on your computer. So if we take a look at the routing table, and we filter only on the Twingate adapter, the Twingate network adapter, which in this case is UTON 8. Then this is the routing table from the perspective of the Twingate network interface. By the way, if you want to replicate this on your computer and you have a Mac, the reason I know this is my interface name is because if I run the DNS command again, it specifies the name of the interface here. That's how I knew which one it was. So let's go back to the routing table, and you'll notice a few things here. So you'll notice a couple of entries that seem to map to private IP addresses in the 192.168.36 range, and all of those IPs in fact correspond to resources that I have legitimate access to. Like for instance, this one is 207.180, which is 207.180 here. And what the routing table says is that the traffic that is meant for this IP address is going to actually be routed via the Twingate network interface. So it's going to effectively be intercepted by the client and sent to a connector. The one that deals with fully qualified domain names is this more generic rule in your routing table, which is on 100.96/12. This is in fact the entire CGNAT IP range. And now I think you're probably connecting the dots a bit more. So what Twingate does is that it tells your computer that it's going to resolve all requests for fully qualified domain names, and all traffic that is going to be directed to the CGNAT IP range is to be processed by the Twingate adapter, by the Twingate client. Remember that this cannot be reserved for anything. So it is a public range that cannot be reserved. So now this range explains why when you do a DNS or a dig of an internal resource with Twingate on, it gives you a CGNAT IP that doesn't actually correspond to the private IP, because this IP is within this range. So it effectively allows Twingate to intercept traffic for Zeus.LAN, pass it to the client, pass it to a connector, and then the connector on its side is going to do the resolution of Zeus.LAN into its private IP. And then it's going to pass traffic to that private IP. But that's why Twingate will return and does the same thing for public traffic. It's just to make sure that, again, CGNAT range, so intercepted by my Twingate network interface via this rule, it's to make sure that the Twingate client can intercept the fully qualified domain name traffic for your resources, send it over to connectors, and then the connectors do the resolution on the other side. So the resolution, while some of it happens on the client side, the resolution really isn't the actual resolution of the private IP or public IP in this case. That's why when you use Twingate and use dig or NS lookup, expect it to return a CGNAT IP instead of the private or public IP of the resource. Now, if we take a look here, this is all summarized here, right? So this is how DNS normally works. Everything goes through default network interface, and DNS queries are resolved usually by your ISP, perhaps Google if you change your DNS resolver. And your ISP is not going to know anything about private domains like twindemo.int. By the way, one thing that's super important to understand is that DNS traffic is not by default encrypted, but Twingate offers DNS over HTTPS, so you can by default encrypt all DNS traffic, whether it's for Twingate resources or not for Twingate resources. And again, this is what happens with a client on. With a client on, the Twingate adapter receives the request for resolution, returns a CGNAT IP, which by definition, because of the routing table on your computer, specifies that all CGNAT IPs have to be processed by the Twingate network interface. It is all of that traffic is passed by Twingates. And like I said, with DOH on, the same thing happens, except that you're also protected for non-Twingate DNS traffic, which by default does not get encrypted. And finally, last reminder, we started this session demonstrating this, but because of the way DNS is handled by Twingates, should you want to use dig, NS lookup, or any DNS troubleshooting command from a client, remember to declare your DNS server as a resource. It could be an IP, it could be a fully qualified domain name, it doesn't matter too much. And then change your resolution commands to explicitly specify which server you expect a response from. That will pass the DNS query to the actual server and return the actual response to your clients. And this is in short how DNS works in Twingate.